is the director of the Institute for Resonance in Boulder, Colorado, which is devoted to the study of subtle energy science, including remote viewing, crop circles, and related subjects. He has earned a PhD in sociology and has previously taught research methodology at Washington State University. He first learned remote viewing in 1996 and became involved in crop circle research. Aside from his systemic crop circle tours, he continues to teach remote viewing in Boulder and in Japan. Dr. Hines' most recent book is Planetary Intelligence. He is here to present implications of the many interacting worlds model of the multiverse for our ideas about human personality structure and paranormal phenomena. Please welcome.
Well, thanks a lot, David. Thanks for inviting me here today. I met some of you last year at SSE in Boulder. It was really fun talking with all of you. And thank you for inviting me to your conference for the first time for myself. My background, as David said, is in sociology. I used to teach statistics, and a couple of years after getting out of graduate school, I came across remote viewing from Dr. Courtney Brown at the Farsight Institute. And to go from teaching linear statistical regression methods to undergraduates to getting involved in remote viewing, as the speaker yesterday said, Stuart Johnson, it kind of blew my mind. Because I came across all sorts of phenomena that I hadn't been prepared for in graduate school. All sorts of topics, some of which we'll talk about right now in my talk here, that just simply didn't fit anything I had ever been taught in 27 years of school. So, like many of you, I've been looking for alternative ideas that would kind of make sense of all these topics of remote viewing, psychokinesis, micro-PK, channeling, UFO contact, all these phenomena that seem to defy our existing paradigms that were officially taught. So, something really has to give here. I want to present to you here some of the research I've been doing in multiverse models that are alternatives to traditional quantum mechanics and how they can explain some of these phenomena and then give some examples at the end, okay? So, if we look at quantum mechanics, the founders of quantum mechanics had to settle with a dualistic model. It's called the Copenhagen interpretation, centered around Niels Bohr and Werner Heisenberg. In the Copenhagen interpretation, and you're all familiar with I'm not going to go over the basics of quantum mechanics here, but you have to understand that for the founders of quantum mechanics, there was no quantum world. They would not be happy with us talking about quantum biology or quantum consciousness or any of this, because for them it was simply quantum measurement. They had to accept the idea that there was this classical world that you and I interact with, the physical level, deterministic, classical, and there's only quantum measurement. And when you're not making the quantum measurements, the quantum world doesn't exist. It was the only way that they could really reconcile superposition and all of the particle wave dualities and the things which we heard about yesterday. And the way they resolved this issue is basically to say that the classical world basically lets us take measurements of quantum processes, but it's basically a mathematical model, and there's nothing going on there that would explain why it does what it does. We just have to be content with the fact that we don't understand it, and it just works the way it does mathematically. But that we don't live in that world, we live in a classical world, the world that we see in our everyday reality. And this led to what's called the preferred basis problem, which is if quantum mechanics tells us that the world is built, our universe is built around a wave, and at the basis of it, it's a quantum wave. Why does reality look to us in the way it does? Why does it seem solid? Why does it have the particular colors and characteristics that we perceive if everything is in a superposition, right? And Schrodinger himself called this jellyfishification. And it really bothered him. There's a really great quote from Schrodinger where he says, how come everything doesn't just look blurry and amorphous? Why don't we all appear like jellyfish to each other? And no one was really ever quite able to resolve the jellyfishification issue. I mean, why don't we perceive macroscopic states. Why do we perceive things as particles and not as waves? Okay. And this bothered him until the end, by the way. Now, it's important to keep in mind that Schrödinger did not invent the wave equation. This actually was discovered by a fellow a long time before, Ernst Florenz Friedrich Chladni. Now, I came across Chladni at SSE when Ron Westrom was telling us about the extraterrestrial discovery of meteorites. And Chladni is better remembered as the person that first came up with the idea that perhaps meteorites could come from beyond our Earth. Because you have to realize, in science at the time, there was a belief based on Aristotle that there was no activity beyond the moon, the superluminary area. Everything was static beyond the moon. So Chladni was the first to suggest that there was an extraterrestrial connection to meteorites. And that's how I came across it. But he actually created this idea of nodal modes. And he created these plates, which I'm told you can see in the Explorer Museum in San Francisco, where he used a bow against a metal plate and created what we all know now as cymatics, right? These kind of patterns that sound can create with sand. You can use lycopodium dust. You're probably all familiar with Dr. Hans Jenny and cymatics and all of this, right? So basically, Chladni worked with, he's known as the father of acoustics, and he was also a physicist. He created these nodal mode patterns and worked out the mathematics for two-dimensional shapes of how sound creates shapes. And more recently, a fellow named Alexander Lauderwasser, and you can see some of this online, did the same thing with water. You can see you can get quite a lot of structure right from sound. Now, Schrödinger, according to my research, didn't have to do any of the math to create the Schrödinger wave equation, at least not for one electron atoms. It was all worked out by mathematicians at the time of Chladni, Bernoulli, Laplace, and others. And Schrödinger didn't even have to do the math. It was all done. He just applied it to the orbitals of one electron atom initially. So the roots of quantum mechanics actually go back to a physical process. It goes back to sound. Chladni also was the inspiration for Michael Faraday, apparently, for acoustic induction, which is quite amazing that you have this one person way back that's, in a sense, the father of classical electromagnetics, and also quantum mechanics. So it goes back to a physical process, and you'll see why that makes sense in a second. So in order to resolve this idea of how do we deal with the particle-wave duality, John von Neumann, who many people say was so smart he was almost seemed like an alien, right? I mean, if you look at the things that he accomplished, it's quite incredible. And he suggested the collapse theory to the measurement problem. In other words, when you take a measurement and you're only getting one aspect of the system, does it collapse the quantum wave to the particle? And he's the one that really proposed the idea of quantum wave collapse. You've all heard of this, I think. And you and I use these terms all the time, but this is where it came from. Now, he also created another important idea, psychophysical parallelism, right? And this is this quote that you'll see quite a bit in conferences like this, because he made reference to extra-physical processes, right? And what really gets me here, is so important, I think, about it, he's suggesting that subjective processes are equal in their stature to objective processes, that they're all real. Subjective and objective states are all equally real. We may perceive the objective ones as more solid, but I think in his mind, if you give a mathematical structure to a subjective process, it would exist in some space, just like an objective process. And some people call this the disappearing worlds theory, quantum wave collapse, because if your perception collapses the quantum wave, where do all the other worlds go? So some people call it the disappearing worlds idea, or don't ask, don't tell. So we know that the quantum wave suggests that there's a superposition for subatomic particles. And by the way, superposition has been extended to larger things than subatomic particles. I believe it's the largest thing that's been put in a superposition is a buckyball, which is a pretty large carbon molecule. But if the object exists in a superposition, where is it when you're not perceiving it? So von Neumann suggested two possibilities, two equations, two axioms. One is that the Schrodinger wave equation governs how particles evolve over time. And secondly, that the act of measurement arbitrarily projects one element of this quantum world onto our classical world and we perceive it. And he made reference to the abstract ego of the observer, collapsing the quantum wave. Now, as you can see, there's a very different quality between axiom 1 and axiom 2. And there was a fellow back in the 1950s who was at Princeton University. I believe he enrolled in 1953. Some of you probably know more about this than me. But basically, Hugh Everett III always thought that there was something wrong with this process of wave collapse. Because for him, and if you think about it, he's really correct in a lot of ways, it's more like metaphysics than physics. It's philosophy. No one's ever seen a quantum wave collapse. It's just kind of assumed to happen. And you have to understand, 100 years ago, 70 to 100 years ago, these physicists were doing the best they could to try to make sense of the paradox here. And so they suggested the idea of wave collapse. Everett believed in the Schrodinger wave equation. He believed that quantum mechanics should be pure, and it shouldn't have to make any reference to a classical world, to the world that we perceive in a classical way. So he accepted the first idea that the Schrodinger wave equation governs the evolution of particles, but not the wave collapse part. He just thought that was an ad hoc thing that was thrown in. And he created what we now know today as the many worlds interpretation of quantum mechanics. Now, it is very interesting to note, as a historical footnote, that that's not what he called it at the time. This is how we refer to it now, because at the time, his dissertation was originally going to be the theory of the universal wave function. He imagined, in a fractal sort of sense, that the wave equation works at a macroscopic level and a microscopic level, and at a macroscopic level. That's all there is the wave equation, and that it never collapses. Now, just as a note, at the time, this was considered heresy. His thesis advisor, John Wheeler, found it so objectionable. And he was especially afraid, John Wheeler, we're told, who was known as a great figure in physics, that he did not want to bother Niels Bohr. This is politics. They were afraid of disturbing the Copenhagen people. And so this multiverse idea was suppressed. The universal wave function was changed to the relativistic state function. You can see where this is going, relativistic states, parallel realities. Every reference to splitting parallel realities was removed from the dissertation, and we didn't find it again until Bryce DeWitt and his wife recovered the original dissertation from his basement. Well, it was actually later on a lot of documents were discovered, but he had to write to Everett and get the original dissertation. There was one copy left. Everett had left physics a long time ago and ended up working with the US government doing nuclear war game planning at the Pentagon. The same process of parallel realities could be applied in computer programming. There's a lot more to that story. But in any case, this theory was suppressed. Now, we knew about it later from Star Trek and other science fiction writers. It was considered too radical at the time. But basically, Everett believed that quantum mechanics should stand on its own, without reference to classical dynamics. That you and I, the observer, we don't stand outside the process. So there's nothing to collapse away. You and I are also in a superposition, right? So who is collapsing whom? This leads to what's called the problem of infinite regression. If I'm observing you and someone's observing me, are we all collapsing each other's waveforms? It becomes kind of illogical after a while. So the observer has no special status in the system. And rather than the waveform being collapsed by the observer is actually sucked into all the different possibilities of the waveform every nanosecond. And that's what leads to the idea of splitting. You become correlated to the system at every single possible point it can be at. And that became known as the many worlds view. Quantum entanglement in this view is simply correlation. And so this leads to the idea that the observer doesn't have any effect on the system, and they're not even aware of their own splitting process, okay? That all the branches exist, and the observer forms a trajectory that forms a tree, not really a line. So it looks like this. If the classical quantum mechanics, we have the typical experiment, and both outcomes are real in a superposition before we actually do the experiment. In the many worlds interpretation, all the possibilities are real, and they split into different worlds every nanosecond, and you're there in all of them. The observer is in all the possible states. Now, some people said, I don't see myself splitting, you know, and everyone would say, well, you don't feel yourself going around the sun either. So, you know, and I've heard people say, I don't like the idea of a million me's. Well, I mean, tough. At least that's what everyone would say. I'm not saying this is how it works. These are just models. Now, Max, if you want to read more about this, Max Tegmark has written some great stuff, The Mathematical Universe. There are many ways you can derive multiverses. This is just one of them. Now, there is a newer model that I want to present here. The Everett model could not assign probabilities to these different states. It did, but no one was quite happy with it. And the different branches in Everett will never interact again. So when you're splitting every nanosecond to perceive all the different possible realities that you could be part of, because of the issue of decoherence, the branches never interact. And Stuart Kaufman talked a little bit about decoherence yesterday. So the branches never interact again. So it's really not that helpful to us. So if Everett wanted to get rid of the quantum wave, many interacting collapse. If you want to get rid of the quantum wave collapse, many interacting worlds want to get rid of the quantum wave, period. It's a radical new theory that instead of saying that these worlds are generated by a splitting process every nanosecond, all of these worlds, it's just posited they exist from the beginning of time, a near infinite number of parallel realities. This is the work of Hall, Deckard, and Wiseman. They published this paper in 2014 about it. And basically, in their model, you can get all of the quantum effects that we're used to, including quantum tunneling, wave packet spreading, and a whole variety of other effects, without the quantum wave. Now, I know what you're thinking. Don't take my quantum wave away from me. I need my quantum wave. But this model actually reproduces quantum effects without a quantum wave. It basically suggests that all quantum phenomena, all of them, are the outcome of a near infinite number of parallel realities that already exist. And it was discovered really independently by Bill Poirier at Austin, Texas, who I've corresponded with a bit, and the people at Griffith University in Australia. But basically, what we perceive in our reality as a quantum wave is the epiphenomena of the interaction between a near infinite number of parallel realities. It doesn't have its own intrinsic reality. Essentially what it is taking the Bohmian idea of a pilot wave, the Burley-Bohm idea of a pilot wave, and integrating that with multiverses. So you basically have a multidimensional pilot wave. And when you have all these worlds interacting, just imagine hundreds of trillions in the same physical space, worlds, right in the space we're in. There's a slight interference pattern between them from the repulsion of electrons that they naturally have to each other. It's a super, super weak effect, but extremely consistent. It would have to be consistent to create the world that we perceive with the quantum effects that we perceive it in. And there's actually evidence in modeling, as I'll show you in a second, that it does reproduce the same quantum effects that we see. It's kind of a shock, right? If you've been around quantum mechanics your whole life, you realize maybe there's something else producing the quantum effects and it's not the quantum wave. I mean, Schrodinger himself said towards the end of his life that he was sorry he got involved in quantum mechanics. So maybe he would have liked this idea. But basically, there are these small repulsive pressures. It's a physical model. It's a quantum pressure model instead of a quantum wave model. And all of these realities create small enough pressure that if they would act in resonance would create the effects we see at our level of reality. And the way I get, if you want to think about this really, the way it seems intuitive to me is you think about rain droplets on a window. I mean, you have all those rain droplets. Some of them just stay there and don't interact. Some of them do interact and form a trickle, and they could form a stream and end up in the ocean, right? So you have all these little particles. Sometimes they don't interact, but if they do begin to interact, you get this resonant coherency, and this is how this model is sort of built. Now, according to this model, based on computer simulations, you only need 41 parallel realities per electron to reproduce many of the quantum experiments we're used to, including double slit quantum tunneling and so forth. And if you look at how it does this, it's actually, even with 2 parallel realities, you get something very close to double slit. The white in the background of this slide, the white color is what you get from the double slit experiment. The blue and red lines are what you would get if you have parallel realities in this model. And as you can see, we don't have a computer powerful enough to model all the realities you need, because this exists in the idea of a continuum limit if you have this near infinite number of parallel realities. But if you do simulate it with just a couple, you end up with something that looks very close to what you get from double slit, and all the other quantum types of effects too. So it's just kind of interesting, why would it be so similar? And I just, doing a back of an envelope calculation, just once calculated, is that, if 99% of our body is made of oxygen, hydrogen, carbon, and how many electrons do we have in our body, and then how many parallel realities would we be interacting with? It's quite a lot. So we'd be interacting with billions and billions of parallel realities. Every second, it's too many to count. But this is what this model suggests. Now, I just want to say it's a model. It doesn't mean it's true, but it's just, you want to see how does this address some of the phenomena that you and I all deal with quite frequently, and say, well, what's the process behind this? Because quantum mechanics has sometimes been referred to as, just shut up and calculate. Don't try to explain your phenomena with this, just do the numbers. And I've talked to physicists, they say, it doesn't explain remote viewing, just leave it alone. So maybe this idea would, because it says, this is one of the creators of MIW, that's what I'll call it, because it's not part of our theory, but the idea of human interactions with other universes is no longer pure fantasy. I mean, that's big, right? And Wiseman said it again in another interview with New Scientist. He said we can no longer rule out communications with other worlds. It's not part of our theory, but think about that. I mean, this is a really serious physics model. A lot of people are looking at it, and it's suggesting that you get communications between worlds. How? These repulsive forces could coherently interact in the same way we have radios, right? At this subatomic level, and recreate a lot of the phenomena that we see that we call paranormal, supernatural. Maybe it's just physics. So I think this has a lot of applications to the topics we're interested here. So basically, this model suggests that you get bleed through from other worlds. Now, I'm sure a lot of you are familiar with the idea of, what is a parallel reality? Just imagine yourself in this exact room with all of us here, but you're wearing a different color shirt. That's another parallel reality. Or you're up here speaking, and I'm sitting in the audience. And every possibility you can imagine exists in all these parallel realities. That's what it's saying. And this model suggests a mechanism by which you can get bleed through, which is for the minimum of 41 parallel realities per electron. Okay? Think about it. So how does this explain? Oh, and there's one more thing about it that's really cool. It has this idea of super non-locality, which basically suggests, and the particles that interact, by the way, how do they interact? It comes from the idea of a configuration space. So it doesn't mean they need to be physically close together to interact, but kind of more like a frequency. If the particles are the same frequency, they could interact. And it actually creates the idea of super non-locality, which means that your particles could be interacting with the particles in another reality, another parallel reality, which in turn could be reacting back to another set of particles here on Earth, which would give you the ability to affect those particles at a distance without even having directly affected them, or kind of indirect connected. of interaction, which is called super non-locality. And when I read that, it seemed to me that this has some relation to PK, micro PK, remote viewing, and so forth, right? Now, I will tell you, you might have heard a lot of things about PK. It's real. I know for a fact that the US government was monitoring Soviet PK experiments in 1976. You're not aware of this because the information was classified. A Soviet psychic was able to bend a spoon at 1,000 miles in 1976. It scared the heck out of the US government, and this is why they kept funding the remote viewing program. It just shows, there's no doubt that it's real. It's just, for some reason, we live in a world where a lot of this information is still classified. And you should be aware that a lot of the people I've been talking about, John von Neumann, Hugh Everett, and many other quantum physicists were involved in the Manhattan Project, and so there's still a lot we don't know. And it's amazing to me that something from 1976 is still classified. It's not classified anymore because you just heard about it. But we're dealing with things that were classified, and that's why a lot of us, we're still trying to figure this out. Maybe someone figured this out, but they never told us, okay? Because they had a security clearance. It's quite complex. In any case, this is the view of the multiverse. It's an ultra-weak, highly precise structure creates the quantum effects we see. Now, how does this apply to our world? I'll give you some examples which I think show that this model may have some real, power to explain some of the phenomena we see. There's this book by Richard Wiseman, not a real friend of our subject matter, in the UK, psychologist. He wrote this book called The As-If Principle, related to William James' theory of psychology that we heard about from the previous speaker. But basically, he made reference to this psychologist in the US. He created this, George Kelly, created this fixed role therapy for people to act like they're another person. And the patients began to say that they felt like they had been that person their entire life. It would make sense with the MIW model because perhaps in the parallel reality, they had been that person. It begins to interact and it seems like I've always been that person, right? Now, you may have seen this movie Split. Recently you've heard about it, about multiple personality disorder, or it's now called dissociative identity disorder, whatever you want to call it. The phenomena in there actually are real. They make reference to the main character, Kevin, the diseases that his body has changed as the personality has changed. This is not fiction, this is actually literally quite true. Now, I first came across this with the channeling. In 1996, after taking Courtney's remote viewing course, I thought I would go to a UFO conference, and I encountered Darryl Anka and Bashar. Some of you may know about Bashar. And this was channeling. Now, this is what Darryl sounds like when he's not.
This is a channeling. A channeling is.
Where is it? Where's my sound file? Okay, so this is what Darryl sounds like when he's not channeling.
This is a channeling. A channeling is a state. I believe personally that channeling is something that everyone can do and that everyone actually does do from time to time. When you get out of your own way, when you allow your own creative energy to come through.
Okay, that's Darryl. Then he changed to Bashar, allegedly, can't prove this is true, allegedly an extraterrestrial from the future. And this is what he sounds like.
Good day to the same time. How are you all? We will take this opportunity once again to thank, first of all, each and every one of you individually and all of you together collectively for allowing for the co-creation of this interaction and this communication through this particular gate on this day, in this way, at this time.
Now, when I first heard this, I thought this was fake. All right?
This is a channeling.
Oh, it's
a channeling is a state.
Well, there you go. I thought that Darryl is the brother of Paul Anka. I thought this was acting.
When you get out of your own way, when you allow your own creative energy to come through.
I thought it was acting. After an hour and a half, I thought, no one can keep talking like that. So what is this? You all listen to channeling, right? You're familiar with channeling. What are we dealing with here? Okay? Is this a bleed through from another reality, as the channels tell us? Is this the many interacting with one? Right? So Bashar has given us some interesting information. Even predicted 9/11 a year before. I was sitting there, he was talking about terror attacks on a couple major US cities, year 2000. So channeling can be accurate. And interesting. Now, It's okay. You may have your own channel to listen to. It's interesting stuff. Where is it coming from? Okay. Has anyone heard of Dr. Fritz in Brazil? Yes, Dr. Fritz. Well, I came across this. It's part of, I met someone doing crop circles in England. By the way, well, it's another talk, but even the ones we've made are crop circles. Quite interesting resonant effects that are very hard to explain. But anyway, I met this guy, Masamaki. He had written this book, In Search of Brazil's Quantum Surgeon. There he is, we were making a crop circle. We had paid the farmer, don't worry. This is an experiment. And, quite fun, you can see. He showed us, he had gone down to, he considered himself a debunker. He had gone down to debunk Dr. Fritz. He couldn't debunk Dr. Fritz. Dr. Fritz is a channel, the group of doctors that are, here he is showing us the pictures of Dr. Fritz operating on people. Without any anesthesia, with circular saws and hammers. Rubens de Ferraris, right? And he's a computer programmer, except when he becomes Dr. Fritz, he doesn't need his glasses. How do you explain that? He's blind as a bat, and yet when he becomes Dr. Fritz, he operates on hundreds of people a day without his glasses, just like you see in the movies. It's a real phenomenon. How do you explain these physiological changes? Well, the model explains that. So I kind of call this the creativity continuum. You can almost imagine that we're all channeling all the time, but what we're channeling is such a consistent personality that you don't see it change enough to think that there's anything paranormal going on. Maybe we're all paranormal, right? But when you see someone do it in a big way, you can see a change. Now, Vincent Furnier, right? You've all heard of him. He changed his name to Alice Cooper after the band. What got me interested in Alice Cooper is that in his movie, Super Duper Alice Cooper, he said that the personality of Alice Cooper was so destructive, he had to banish him from his life. He could be Alice Cooper on stage, but when he was off stage, that character was too destructive. It's not just acting, it actually took over his life. And I'm sure you're aware of other actors that have talked about this. You know, Alice Cooper suffered from alcoholism and drug abuse. He got better once he decided to be Vince Furnier off stage again, right? And then there's the actor Jeremy Brett. He played Sherlock Holmes. You might have seen this. I love this in the 80s and 90s. You know, he's a great actor, just super. My brother's named after him, Jeremy. And you know, it actually ended up kind of killing him. He said it was dangerous to be Sherlock Holmes. Jeremy Brett was such a good actor. He moved to Baker Street. Do you know this? He started smoking, and who knows what else he did. He was smoking 60 cigarettes a day at the time he was dead, just like Sherlock Holmes would. He said, you absorb the character like a liquid. You know, the MIW model is a hydrodynamics-based model. It's based on pressure. It sounds like the same sort of thing. And then he said, playing Sherlock Holmes, it all got too dangerous. And then he died. way too young. And then lastly, there's the case of, you know, Chris Costner Sizemore, who was became the movie Three Faces of Eve. One of the characters was allergic to nylon, the other wasn't. So these physiological changes show us, even related to channeling, this is not just acting, this is not just subjective, going back to psychophysical parallelism. These are real objective states, but how does someone change that quickly? So you have to ask yourself, do we live in a sort of a flatland from our level of perception, but there's a higher level of reality? And these realities bleed through, they interact through some sort of resonance. And you'd end up concluding that reality leaks. Now, if you don't like living in a reality that leaks, you could find another multiverse, perhaps, where it doesn't leak. But it seems that perhaps ours does. And I think the biggest impact of all this, it suggests that the phenomena we've been calling supernatural, paranormal, and maybe they're just normal or natural. And maybe in a multiverse, that's what you get. So you may have to give up the quantum wave, but what you get is a multiverse. So think about it. So anyway, thanks very much. That's my presentation. Any questions?